So I created this class to demonstrate some of the methods from the string class. So the name of my class matches the name of my file. I'm going to go ahead and create some string variables. So the first one I'm going to create is the traditional way where I'm going to assign an object reference variable to a string literal. And the second way I'm going to create a variable is I'm going to use the constructor and the new operator. Using the constructor and the new operator for a string is normally not done because we have this easier syntax to instantiate a string object. So it just kind of makes less sense to use this because it's more typing. But these two work exactly the same, so I'm going to go ahead and print out these results. So I'm printing my two string object reference variables, so I'm going to go ahead and compile and run this program, and there are the results. So a string is an object. So what exactly does that mean? That means it's not just data, there's characteristics and behaviors associated with that. And the behaviors are the methods that you can invoke on a string. If you look back into the book, you can see that they gave you a list of methods that you can use. I'm going to go through all the examples from the book, and I'm also going to introduce other methods from the Java API that I think are useful. So the first thing I want to demonstrate is the 2 uppercase and 2 lowercase. So I'm going to go ahead and invoke those 2 methods on my first name, and then I'm going to print my first name back out so you can see that the object did not actually change. So here I'm getting my first name, I'm invoking the method 2 lowercase, and I'm invoking the method 2 uppercase, and then I'm printing out the first name once more so that we can see that my first name didn't actually change. So the string object is immutable, so I want to print this out so that I can see I still have my original value, which is Michael with the uppercase M. I'm going to go ahead and compile and run, and you can see the results. So 2 lowercase just made everything in lowercase, 2 uppercase made everything in uppercase, but when I print out the results of my first name, it's still Michael. So I'm going to go ahead and demonstrate a few more methods. Alright, so I added a few more lines. I wanted to just demonstrate some of the easier methods. The first one is the char at. Now char at, I'm passing in index 3. Now remember, at index 3 is actually the 4th character because I started at index 0. Then I'm calling length on my first name, length on my last name, and then I'm doing a replace. So I'm saying in my last name, replace A with O, and then the last thing I'm doing is I'm printing out my original values so that we can see the values did not actually change. So whenever I do something like replace, I'm generating a new string. It's taking my original string for my last name and making a modified version of that string. So my last name object is going to stay the same. So I'm going to go ahead and compile and run. And you can see that char at 3 in my first name is H. It's the 4th character because the capital M is at index 0. And then it's saying the length of my first name is 7. The length of my last name is 8. I replaced A with O, so I got the result of my last name, but I'm using an O instead of the A. And you can see there are my original values for my first and my last name. Now, what do you think will happen if I were to call char at, but I would go outside of my range? Now, we talked about this. Now, what's going to happen is in my first name, the very last character is L, and my first name is 7 characters long. But since we start off at index 0, the last character is at index 6. So I'm going to go ahead and demonstrate that. I'm going to put char at 6, and then I'm going to compile and run this program. You can see that there is an L at index 6. So now what I want to do is I want to go past that. I want to go to 7, and we can see what happens. I modified this to 7. Now, since my first name is only 7 characters long, index 7 does not exist in my first name because the last character is at index 6. So let's see what happens when I compile. So it does compile, but let's see what happens when I run. So when I run, I get an exception like right when I try to use that method. And it's telling me that at index 7, out of the range of the string. So Java knew at that point, hey, your string is only 7 characters long. There is no index 7. And it just crashed at that moment. So I added a few more method calls. I wanted to test the compare to. So in the first case, I'm comparing my first name to my last name. Second case, I'm comparing my last name to my first name. And then my last case, I'm comparing first name to itself. So if you remember from the description in the book, if first name is considered to be less than last name, then this is going to result into a negative number. If first name is considered to be greater than last name, it's going to result in a positive number. If first name and last name are considered to be equal, then the result of this would be 0. So let me compile and run. And here are my results. So first name is considered to be greater than my last name. Last name is considered to be less than my first name. And when I compared my first name to my first name, I got a 0, so that means they're considered to be equal. Now, the reason why the first name is considered to be greater than my last name is because the first character, they both have a capital M. The second character, my first name has an I, my last name has an A. Now, the lowercase a comes before the lowercase I in the Unicode character set, so that means that a has a smaller value. So whenever Java does any string comparisons, it's actually taking that number from the Unicode character set to do its comparison. So I added the equals method check. So I wanted to check the equals method, and I set up a few different scenarios. So the first scenario is I'm checking to see if first is equal to last, and I'm checking if last is equal to first, and then I'm checking if first is equal to first, and then I'm checking if first is equal to first in all uppercase. And then the last check I'm doing is I'm checking to see if first is equal to first in all uppercase, but I'm calling equals ignore case. So let's look at the results. So first does not equal to last, it returned false. Last does not equal to first, returned false, but first does equal to first. I mean, that makes sense. Returns true. Now, first does not equal to first in all caps. That returned a false. But when I did the ignore case, it returned true. So if I wanted to ignore case, then I would call equals ignore case. And I compared my first name to my first name in all uppercase. So the next example is a concat method. Now, this is a very simple method. It just joins the two strings together. So if I invoke concat on my first name and I pass it my last name, it's going to join in my first and my last name, just as I did as ever to add them together, just like what I did here. So let me go ahead and compile and run. And here are my results. So the last method from the book to demonstrate is substring. The way this works is you pass in the index of where you want to start, and then you pass in the index of where you want to stop. So index 1 is I, because 1 is the second character in my first name, and index 4 is the A, because it's the fifth character in my first name. But you actually want to stop at 4 minus 1. So if we put in a 4, that means we're going to stop right before 4, right? So A is at index 4, so that means we're going to stop at C. So I should expect to see ICH for this substring. Now the next example, it's substring, but we're only passing in where we want to start. So we want to start at index 2. So index 2 is where my C is at in my first name. It's going to start at C, and it's going to give me the rest of my first name. So it's going to be C, then all the way to the end of my first name. So let's compile and run, and there's the results. So it started at index 1, which is the second character, I. Now the fourth character is A, so it stopped before A. And then the substring 2, it started at the second character and printed everything out after that second character. So I created this program because I wanted to demonstrate a few more string methods. So it's just a real simple program. I have a scanner class, and I prompt the user for his first name, last name, and his favorite number. I store the data into a string for the first name and the last name. I store the data into an integer for his favorite number, and then I just simply print out the values back to the user. So I'm going to go ahead and compile and run this program so we can see what it looks like. So I'm being prompted for my first name, last name, and then my favorite number. And I'm going to run this program again, but this time I'm going to put spaces in front and at the end. And you can see when I print out the data that I entered for the first and the last name, I have all this extra space in front of my first and my last name. But for my favorite number, I didn't. And the reason why is the number was a token scan. So I went ahead and only scanned in the integer. It didn't scan in any of the white space. But when I do my line scan, I'm scanning in the entire line. So that's including all the white space. So there are methods to kind of handle this. And one of those methods is trim. Trim method will remove any white space before and after your string. So I'm going to go ahead and do that. Scan.nextLine is actually a string. So I can actually invoke this right here. I can invoke trim there, and I can invoke trim right here. Now I'm going to go ahead and compile and run this program. And now when I put in white space, you can see in my result that extra white space got trimmed off. Now what I want to do is add to this program. I'm already prompting a user for his first, his last name, and his favorite number, but I want to generate a login name for this user, where the login name will be in all lowercase, and it'll be the first letter of his first name and the first three letters of his last name, followed by his favorite number. So I'm going to create a variable to hold this information, and that variable is going to be login name. So now when I use string methods to generate my login name, I'm going to do this after I print out the information. So there's several ways to do this. So the first way I'm going to do this is I'm going to take it one step at a time, and then we can see what happens and fix our errors. First thing I want to do is I want to grab the first character off the first name. Now already I have a problem. Let's see what happens when I compile. So when I compile, Java's telling me that this is a char, and I'm trying to set that to a string. So I'm basically saying the string is equal to this char. These are two different data types, so Java's upset. Now if I wanted to convert this char over to a string, there's a static method on the string class called value of. So the way I'm going to do this is I'm going to invoke that method through the class name. So I'm invoking value of through the class name. So this is a static method, meaning you don't need an object of the string class in order to invoke this method. This is going to convert this character into a string so that I can assign it to login. Now that I have the first letter of my first name, I want to grab the first three letters of my last name. So to do that, I'm going to use substring. So I'm going to start at the first letter, and then I'm going to grab up to the third character. So the third character is at index 2, and then I add 1 to that, so it's a 3. If you remember, the last number you pass into the substring is the number of where you want to stop. Now I want to go ahead and concatenate in my favorite number and print the results. So I'm concatenating the favorite number and I'm printing the results. Let's go ahead and compile and run this program. And here are the results. I grabbed the first character of my first name, the first 3 of my last name, and then my favorite number. I want login name to be in lowercase, so what I'm going to do is assign login name to itself, but in lowercase. I'm going to go ahead and compile and run this program, and there are my results. So I introduced the trim method, and then I also introduced the static method of value of. The other static method I want to introduce is format. I'm going to go ahead and redo this example, but using the string.format, and it works exactly like the printf, except it's going to return a string. So I'm going to go ahead and change this so that I'm using string.format. So I'm using the format method on the string class, which is a static method. So we invoke it through the class name. Like I said, it works exactly like printf. So I'm using these flags here. I'm doing a string, and an integer. So the values I'm passing in is the first character of my first name, and then the first 3 of my last name, and then my favorite number. So here's the first string, here's the second string, and then here's the number. Now the one thing I'm not doing is taking it to lowercase. So since everything that's highlighted is a string, I can invoke 2 lowercase on whatever is highlighted, because this entire thing here is a string. So I'm going to do 2 lowercase, and you're going to see that this works exactly the same as what I did up here. So compile, run, and there's my results. Alright, so back to the lecture. Let's finish the string section. So here's a quick check. So what output is produced by the following? They have a string variable and they're setting it to space the final frontier. They're grabbing the length, they're grabbing the substring, they're saying 2 uppercase, and they're grabbing the length again. So the length of the string is going to be the same for the top one and for the bottom one, right? A string is immutable, so the length will not change. So the number of characters that are in here is going to be the same for this first line and this second line. And then the substring at 7, that just means they're going to start at the index of 7. So that means they're going to start at the 8th spot. So if you count the characters, the T is at the 8th spot, which is at index 7. So that line is going to generate a substring of the final frontier, and then you're taking it to uppercase. So it's just simply going to make this in all uppercase. So here's the results. They're saying that the length of that is 26. The substring starting at index 7 is the final frontier, and then the string in all caps is space the final frontier, and then the length is still 26 on this last line.